Hello everybody, we're going to look at number 4 right now in the quiz. It says a point moves on the x-axis in a way such that its velocity at time when t is greater than 0, this is actually important, is given by v equals ln of t over t. So normally, see, this equation, it's the same thing as if I had v of t equals ln of t over t. Note, v of t is just the function, what it's a function of. At what value of t, so this is just, I want to find t. When it says value of t, this basically means find t when v, when it says here, does v attain its maximum, when v is at its maximum. So what we have to do is recognize our keywords. The keyword is maximum. If you remember from number 3, whenever it says max or minimum, this implies you're going to take the derivative and set it equal to 0. Okay, so this is basically the key over here. Whenever you see that word max or min, take the derivative and set it equal to 0. So we're going to do that right now. Also, you might want to see when you're done, you also want to use the first derivative test when you're done. Sometimes you won't need it though, so you have to, it just depends on the problem. You notice here they didn't really give us that many choices, so what I'm guessing is in a problem like this there's only going to be one value. But to even figure that out, let's just take the derivative and see what we get. So we know v of t is equal to ln of t over t, so this implies that v prime of t, which is the same as a of t, is equal to this is the quotient rule, low, so low d. Notice I'm writing d dt because all of these are t's here. So I'm going to take the derivative with respect to t, d dt of the ln of t, low d high minus high d low. The derivative of t with respect to t is times 1, all over low is t squared. Rewriting t times the derivative of ln of t with respect to t is 1 over t times, minus ln of t times 1 is just ln of t all over t squared, right? So now what we do is we simplify. So what do we get? 1 over t times t is just 1, so t over t is 1, right? Minus ln of t over t squared. And so I have taken the derivative, right? And now I need to set it equal to 0, because I want to find those critical numbers, so those extreme values, right? So I set it equal to 0. And now we're going to solve this here. Now, if you recall here, there's two things we need to look for. We need to find where f prime is 0, right? And where f prime does not exist. Okay? Now, as you can see here, we have a value where f prime does not exist, or and this, whatever your function is. In this case, v prime, right? I mean, it's the same thing as f, right? So we need to find where v prime is 0 and where v prime, d, and e. See, it does not exist at 0. Why? Because I cannot put a 0 in my for the value of t. So this implies we do have a critical point at t equals 0. But this is true. However, if you look at the problem, the function is only defined for when t is greater than 0. So we don't need to worry about this one. So we don't need to worry about that. So this, as far as this part goes, we are off the hook because that was the only value where the derivative didn't exist. So now we just need to find this part here, or this part. It's the same thing where the derivative is 0. So I'm going to continue to solve this. I'm going to multiply by t squared to both sides. And what I end up getting now is 1 minus L, the natural log of t, equals 0. I'm going to subtract 1 from both sides. And I get negative natural log of t equals negative 1. I divide by negative 1, so I get ln of t equals 1. Now, this is base E. I'm going to transpose. So little e becomes big E. So it becomes e to the 1 equals my t. So t is just e. In this case, there was only one value, and I don't really need to test here. So notice I said here we want to use the first derivative test. However, there was only one value here. They only gave us one value, and so we're assuming that it's the value they're talking about here, which in the problem they say it's max here. And so because we have only 2 minutes per question, we don't want to waste any time, and so the answer clearly is just C. It's not A. I wrote that incorrectly.